Hi everyone. In today's video, let us discuss how to dismantling and assembling of solenoid valve. At the end of this, you shall be able to remove the nut, to remove the coil, remove the core or metal plate, remove the valve, check for scratches, clean and reassemble.
Objectives. At the end of this, you shall be able to remove the nut, to remove the coil, remove the cores or metal plate, remove the valve, check for scratches, clean and reassemble. Let us discuss about solenoid valves. Solenoid valves are control units that, when electrically energized or de-energized, either shut off or allow fluid flow. The actuator takes the form of an electromagnet. When energized, a magnetic field builds up, which pulls a plunger or pivoted armature against the action of a spring. Direct solenoid valves. A solenoid and a valve body make up the two primary parts of a solenoid valve. An iron core known as the plunger surrounds an electromagnetically inductive coil at the center of a solenoid. It may be usually open or normally closed when at rest. A usually closed valve is closed and a normally open valve is open in the de-energized state. The solenoid's coil is energized and produces a magnetic field when current runs through it. This moves the plunger and displaces the spring force by creating a magnetic attraction between them. If the valve is ordinarily closed, lifting the plunger causes the seal to open the orifice and let the media flow through. The solenoid valve's magnetic force and orifice diameter have a direct impact on the maximum operating pressure and flow rate. Consequently, for relatively low flow rates, a direct acting solenoid valve is commonly used. Direct operated solenoid valves can be utilized from 0 bar to the maximum permitted pressure because they have no minimum operating pressure or pressure difference requirements. Indirect solenoid valves. The pressure difference of the medium over the valve's input and outlet ports is used by indirect acting solenoid valves, also known as servo-operated or pilot-operated valves, to open and close the valve. They normally need a minimum pressure differential of about 0.5 bar as a result. A diaphragm, which is another name for a rubber membrane, separates the inlet and output ports. A tiny hole in the membrane allows the medium to pass from the entrance to the top compartment. A typically closed indirect acting solenoid valve will stay closed as long as the inlet pressure above the membrane and supporting spring are present. A narrow passage links the low pressure port to the chamber above the membrane. The plunger and valve seal restricts this connection when the valve is closed. This pilot orifice has a diameter that is greater than the membrane hole's diameter. The pilot orifice opens when the solenoid is activated, which lowers the pressure above the membrane. The membrane will be elevated as a result of the pressure difference on each side of the membrane, allowing the medium to flow from the inlet port to the output port. The identical parts make up a typically open valve, which operates in the opposite manner. Semi-direct solenoid valves. Indirect and direct valve characteristics are combined in semi-direct acting solenoid valves. Because of this, they can operate at 0 bar while still having a high flow rate. They have a movable membrane with a tiny opening and pressure chambers on both sides, and they resemble indirect valves in appearance. The solenoid plunger is directly attached to the membrane, which is the difference. The membrane is directly lifted when the plunger is raised, opening the valve. The plunger simultaneously causes a second hole in the membrane, which has a slightly bigger diameter than the first orifice to open. As a result, there is a decrease in pressure in the chamber above the membrane. As a result, the membrane is raised by both the pressure difference and the plunger. This combination produces a valve that can manage reasonably high flow rates and can function at 0 bar. Semi-direct operated valves frequently have coils that are more potent than indirect operated valves. Assisted lift solenoid valves are another name for semi-direct operated valves. Selection of solenoid valve. Before choosing a solenoid valve, it is imperative to have a thorough understanding of your application. Type. Ascertain if a two-way or three-way solenoid valve is needed for your application. Input voltage. Depending on the availability of power supply, solenoid valves can be found in both AC and DC power supplies. Valve function. You have the option of selecting a generally open or normally closed valve depending on the operating time period. Most solenoid valves are typically closed while not in use. A typically open valve is recommended if the valve's opening time is longer than its shutting time and vice versa. And another choice is bistable or latching. Pressure. For your application, the valve needs to be able to resist the highest pressure possible. The minimum pressure should also be noted because a high pressure differential can lead to valve failure. Operation type. Determine the type of operation needed for your application, whether it calls for a direct, indirect, or semi-direct operated solenoid valve. Seal material. The chemistry and temperature of the media should be taken into consideration while choosing the seal material. Common choices include NBR, nitrile butadiene rubber, EPDM, ethylene propylene diene monomer, FKM, fluorine caustic material Viton, and PTFE, polytetrafluoroethylene Teflon. Refer for rapid access to information on seal materials, chemical resistance. Choose the appropriate seal material for your solenoid valve. Housing material. Based on the media's chemical composition, temperature, and environment, choose the material for the valve housing. Typically, brass is utilized for neutral media. The chemical, temperature, and pressure resistance of stainless steel is good. Because they are economical, PVC and polyamide are frequently used. Applications. Solenoid valves are used in refrigeration systems to change the direction of refrigerant flow. This aids in heating during the winter and cooling during the summer. Automation control solenoid valves are used in irrigation systems. Solenoid valves are used in washing machines and dishwashers to regulate water flow. Solenoid valves are used in air conditioning systems to regulate air pressure. In automatic locking systems for door locks, solenoid valves are utilized. The flow, direction, and pressure of the fluid are controlled by solenoid valves in medical and dental equipment. Solenoid valves are frequently used in conjunction with float switches in water tanks to regulate the inflow or outflow of water. Controlling the water and soap flow in car washes, equipment for industrial cleaning. Let us discuss in practical. Task 1.
Dismantling and assembling of solenoid valve.
Step 1. The assembled valve looks like. First thing to note is that the valve actually is two major components, the coil and the valve mechanism. You can safely remove the coil even while the valve itself is connected to the water supply and under itself is connected to the water supply and under pressure. Removal of the coil itself will not cause the water to flow and will not cause the valve to leak water. Step 2. Remove the top nut to remove the coil. For the following steps are disassembling the valve itself. For this, you need the water turned off and even then you will get a slight amount of water out of the system when you take the valve apart. Step 3. Here, note the two screws holding the metal plate on. We will remove these to disassemble the valve. Step 4. Now remove the two screws. Step 5. Now remove the metal plate. Step 6. Now with the twisting motion, grab the valve stem and pull it upward. The valve with the stem removed. Step 7. Now the stem itself can be disassembled and cleaned. Note that the plunger with the spring should just fall out of the stem. Step 8. Observe inside the stem and the surface of the plunger and clean any trace of foreign objects. Task 2. If you ever need to disassemble a A37 IRU, Z, and 0, AC 220 volt water or air solenoid valve. Here is a step-by-step pictorial. Step 1. The front and back gate valves on the water solenoid valve's main valve should be closed. Step 2. To release the pressure inside the water solenoid valve, loosen the pipe junction screw on the main valve lid. Step 3. In addition to the nuts on the copper tubes in the control pipeline, remove all of the screws from the water solenoid valve. Step 4. Remove the bonnet and take out the spring. Step 5. Take out the piston, diaphragm, shaft core, etc. Diaphragm injury must be avoided. Step 6. After removing the aforementioned pieces, examine the diaphragm and O-ring to see whether they have any damage. Please put an end to disassembling the internal components if there is no damage. Step 7. Look closely to see whether the shaft core and primary valve seat have any damage. The water solenoid valve's main valve should be cleaned out if there is any additional junk within. Step 8. Assemble the components and pieces in the main valve in the opposite sequence. Please be aware that you cannot block the water solenoid valve.
I hope you can disassemble and reassemble the solenoid valves after watching this video. Thank you for watching and have a great day.